Good morning, good afternoon, and good evening, everyone, depending upon where you have joined from. Welcome to another webinar by Data Platform Geeks. Today, our webinar is on data virtualization in SQL Server 2019 Big Data Clusters. And our speaker for today's session is Niels Berglund, who is the Data Platform MVP from South Africa. My name is Aarti Nambiar, and I'll be your host for the next few minutes. And Sonal Badka is helping me with the moderation. Before moving on with the webinar, I have a couple of slides to share. We represent Data Platform Geeks and SQL Server Geeks communities, which are two separate communities, and there are different websites as well. Dataplatformgeeks.com and SQLServerGeeks.com. Log into dataplatformgeeks.com to know more about our upcoming events and webinars. You can also get access to all the webinar recordings, resources, blogs, etc. In SQL Server Geeks, we will find lots of technical videos, blogs, etc. Once in a year, we do this learning event called as Data Platform Summit in Bangalore, India. So you can check out our social media channels. If you wish to follow us or join us in any of the social channels and remain updated on our activities, you can check out the links in the chat window. So this is the link bit.ly/dpgsocial. As I was talking about our learning event called Data Platform Summit, this is the 6th year that we'll be organizing this event. You can see the themes for all 5 years on the right side of the screen. We'll be announcing the dates for DPS 2020 shortly. Here is a group picture taken at Data Platform Summit 2019, which we had organized in the month of August in Bangalore. More than 1,000 people had attended the conference who had traveled from 16 different countries. There were more than 100 sessions which had been delivered by over 60 plus speakers from 20 different countries. If you are a person who works with data, analytics, or AI related technologies, this is a must attend summit for you. Here in this conference, you get to network and learn from the product makers, MVPs, and Microsoft certified masters, industry veterans, and your peers from different industries and all over the world. A big thanks to our core team members who spend time from their schedules to contribute to the community. Amit Bansal, who is the founder and president, and Manohar Punna, the vice president, Avnish Panchal, Vijay Mishra, Vijay Reddy, Anupama Natarajan, Sandeep Pani, Prince Rastogi, Surbhi Agarwal, Shakaram Sinde, and Devdatta Nand. Apart from the DPG team, eDomina teams also help us with organizing and managing the events across India. Special thanks to Microsoft for helping us with our community efforts. Our today's knowledge partner is SQL Maestros. You can visit the website www.sqlmaestros.com to know more about their offerings like hands-on labs and video courses. Video courses on SQL Server performance tuning and T-SQL querying and programming will be launched shortly. If you wish to learn more about the SQL Maestros, you can visit the website www.sqlmaestros.com or simply drop an email to contact@sqlmaestros.com. You're all members of Data Platform Geeks. Remain as a member to get notified on all our in-person events pan-India and also the webinars. You will get access to lots of free videos, labs, magazines, etc. Once in a while, we even put up free hands-on labs for the community. Kindly whitelist Data Platform Geeks domain and add events at Data Platform Geeks to your address book so you don't miss out any of our events. So the links to are given in the chat window. Beyond this webinar, if you have any questions, you can join our social channels and post your queries there. We will pass it on to the speakers or someone else from the community will as well answer them. So bit.ly/DPG social is the link where you can find links to all our Facebook, LinkedIn, Twitter, Telegram channels. You can follow us or join us as per your preferred social channel so that you remain connected and notified. So without any further delay, let me hand it over to the speaker. Before that, we have a poll. If you can please answer to the poll. So I hope you can see the polls in your screen. There are two questions in the polls. How many of you have attended the previous webinar by Niels Berglund on a lab around SQL Server 2019 Big Data Cluster in December? So you can give either yes or no if you have attended. And the next question is, how many are working with SQL Server 2019 Big Data Cluster actively? I'll give a few more seconds so that we'll wait for the poll. So the poll has ended. Niels, 84% of the people have not attended the previous webinar in December. And we have about 75% of people who don't work on big data clusters.
Okay, thank you so much. Can you guys hear me?
Yeah, we can hear you. Neil, you can,
Cool.
Neil, you can share your screen.
Yeah, I'll share my screen now. You need to stop sharing, I think.
Yeah.
Right, I should be sharing now. If you guys can tell me if you see the screen.
Yes, Niels, your screen is visible.
Cool. Awesome. Thank you so much. Once again, good morning, good afternoon, good evening to all that is attending, dependent upon the time zone you're in. Right now it is 11:40 here in South Africa in Durban. And let me tell you a story before we begin. There was a slight panic this morning. I woke up at around 5 o'clock and I was going to start to looking at the presentation, etc. And all of a sudden, the electricity went off. And we were without electricity for 3-4 hours. I sent panicky emails through my phone to the organizers and said, "Hey guys, we may have to do something about this." And then, but fortunately, electricity came back, and then it went off again. Bummer, but yeah. Well, as you can see, we're up and running. That's good. So let's get started. So in this webinar, we're talking about data virtualization in SQL Server 2019 big data cluster. And my name is Niels Berglund. I'm a software architect at the company here in Durban called Derivco. We are doing software for online gambling. I've written a couple of books. As we said in the beginning, and I'm a data platform MVP. And I work quite closely with Microsoft around SQL Server. So that's who I am. Right. So today, what we're going to do is the agenda for today looks something like this. We'll start talking a little bit about data. For you who attended my webinar back in December, some of this will be of the first slides will probably be a little bit a repeat, but anyway, so we'll talk about data. Then we'll talk a little bit about SQL Server and data integration. We go on to talk about Polybase, what that is. We'll look at the big data cluster, the 2019 big data cluster and data virtualization in the cluster. And then we'll finish off to look at something called pools in SQL Server 2019 big data cluster. We'll talk a little bit about compute pool, the storage pool, and the data pool. But I'll just mention that briefly at the very end here. If you join the webinar on Thursday and the day after tomorrow, we'll talk more about the storage pools and the data pools. So that's what we're going to do today. After the webinar, I'll share out the slides as well as the code so you can go off and try on your own. Right, so if we think about data, I mean, throughout the centuries, we have always had data. I mean, Moses came down with the tablets, and that was data. Cavemans were doing things in the caves, had pictures, etc. That's data. And throughout the years, we are amassing more and more and more data. And there has been some investigation, some research, and saying in 2016, we had around 16.1 zettabytes worth of data. Zettabytes is a billion terabytes, so it's a lot. However, it is estimated that in 2025, i.e. only 9 years afterwards, we have multiplied that data amount tenfold to up to 163 zettabytes. I don't really know who is looking at, coming up with these figures and how they're getting it, but what I do know is that we have lots and lots and lots of data. And this data is kind of, I mean, it's not stored in SQL Server, right? We're having it in relational databases, obviously, but we have it also all over the place. We have it in Excel spreadsheets, we have it in a Hadoop file system, we have it in God forbid, Oracle, we have it in NoSQL databases, etc., etc. And the question now, if we want to remain competitive in whatever things we do, we need to be able to handle this data. We need to be able to analyze this data, to get insight into this data, to stay a step ahead of the competition. And if we don't do it, you can bet that your competitors are doing it. So the question is now, how do we manage all this data? If you look at SQL Server, so I'm an old guy, so I remember back in the day when we had SQL Server 1.0, which was for this awesome new operating system that Microsoft cooperated with IBM on, the OS2. Well, we know what happened to OS2, but SQL Server kind of continued, and throughout the years, Microsoft has added functionality and features to SQL Server. I mean, back in the day, SQL 4.2 had the same code base as Sybase. We eventually split the code base when we came up to SQL Server 7. And SQL Server 7 was probably the, well, I don't want to say it, but I'll say it anyway. The first really usable version of SQL Server, right? But Microsoft has added things, right? So it's not anymore just a relational database. As Microsoft added back when analysis services. Microsoft added SQL Server integration services. Microsoft added in the SQL Server 2005 version, which is a huge favorite of mine, Microsoft added new data types, amongst them XML. They added SQL CLR to be able to do cool stuff inside the database. So throughout the years, SQL Server has evolved, and SQL 2017 was a landmark whereby Microsoft released it in being able to run on Linux, in Linux containers. And I mean, that is absolutely huge. Microsoft and Linux, they were kind of sworn enemies back in the day. I remember a conference where Steve Ballmer, the head, well, at the time he was CEO of Microsoft, he stood up and said at this conference in front of thousands and thousands of people, Linux is a cancer, right? And now, 10, 20 years later, SQL Server, Microsoft's flagship product, runs on Linux. That's awesome. And now, 2019, Microsoft is releasing not only SQL Server 2019, the SQL we know and love, but also SQL Server Big Data Cluster, which basically runs in Linux container on Kubernetes. And I spoke about that in my previous webinar last year. Well, actually last decade even. But anyway, so the answer here, so what Microsoft tries to do is to make SQL Server the hub for all your data. So to manage all the, integrate all data, and also analyze all data. Please remember that back in SQL 2016, Microsoft introduced the ability to execute R scripts from inside SQL Server, and then in 2017 that was we added Python support, and in 2019 we can now call Java code from inside SQL Server, and all of a sudden, right, Microsoft and Java, they are tightly coupled. That's another interesting thing to think about in the evolution of SQL Server or Microsoft, etc. And so in this webinar, it's this integrate all data that we will mostly look at. We'll talk a little bit about manage all data as well, but it's the data integration that we will look at, that we get in SQL Server 2019 Big Data Cluster, and also actually to an extent in your bog standard SQL Server 2019. Right, so how do we integrate data? What methods do we have to when we are doing data integration? And you guys and girls that has been around a little while, you're probably aware. So we're having here on this side, right? We're having now a source database, right? That may be an OLTP database. I don't know what it is. And we now want to extract data from there. So we're running some ELT, ETL processes where we are moving that into this database here. I'm not very good at drawing, but anyway, we're moving that into this database here, which we then from here can query, analyze, etc. So that's, we'll talk about potential downsides to this in a little bit, right? So that's one way of doing this. And I would guess that you guys that are working with SQL Server daily, you are used to this. You're having a source database, you are doing ETL, it could be through SSIS, through replication, whatever, and you're moving that data into some other database. And God knows in the Rivco where I work, by the way, we probably have the biggest SQL install bases in the world. So we are running our business all over the world on SQL servers. We have probably 500-600 server instances running in data centers around the world, and we are doing a lot of this. We are replicating data from a source to another database, to another database, to another database. Right? The other way to do data integration is we, instead of moving the data, we are virtualizing the data. So in essence, we are, the data sits here. We are not moving it, right? But we are then, what we are doing is we are we are some technical difficulties. We are virtualizing the data in this database. We are virtualizing it in this database, and when we are querying, doing analysis, the queries is kind of going through back to the original source. And the only thing that we are moving here is the result data. We are not moving 5 billion rows to be able to create a result consisting of 10,000, 100,000, 200,000 rows of data. We are doing everything against the source database through virtualization in this database. Right. So if we're then looking at, if we're going back to and look at data movement here on the left-hand side, the downsides here is, I mean, we obviously there's a cost side to this, because if we are moving data from source to this our database, well, we are duplicating. Also, we most likely we are doing this movement in batch jobs. So the data may not be up to date here in my database, because we haven't moved it from the source database. So it will take a little while before we actually can do anything with the data, and that's dependent upon the business you're in. it may have a big impact. Security, I mean, our security department, they absolutely hate it when we're moving data around, because they don't really know what's happening with the data, and they don't want the data to be moved. We have all this GDPR, PII, all that stuff. So moving data is not really good for that. What if we're missing some data? Right, so the quality, right? It may, during the transport here, maybe we are missing some data, and all of a sudden we do not have a true representation of the data in here in the source database. And once again, compliance, as I said, security is not happy if we're moving GDPR, PII, all that good stuff, or well, maybe not that good stuff, but so there are aspects to this where we are moving data may not be optimal. With data virtualization, obviously, right? We only have positives here. And certain things are right here, that we have a lower storage cost. We can more rapidly work against the data in the source. We don't need to wait for it to be moved to our database. One thing is for certain, and that is that we have fresh data because we are querying the source. A downside, though, so let me just mention that the downside here is that as we are now going from here, right, all the way down to the source and then coming back, the latency of the actual query may be higher. So that is something that when we are working with this, we need to look at, is that acceptable? Are the pros outweighing the cons? In other words, we are getting more fresh data, etc., etc., etc. Right. Okay, so if you're then looking at SQL, so SQL Server, throughout the years, we've had data virtualization in SQL Server. And we still have something called linked servers. And I don't know about you guys, but I do not like linked servers at all. They are just a lot of trouble. And back in the day, back in the SQL 2005 days, you really couldn't do that much with linked server. Or well, you could query, but you couldn't. Back then, they didn't support the var max type like nvarchar max and var binary max or XML or whatever. And it actually went back in the Rivco back then, like 10 years ago. So I wrote some SQL CLR code. I told you I loved SQL CLR. I of linked servers that didn't have all these downsides that we had back then. We are still running it, so yeah, I must have done something right. So linked servers. Then when the analytics platform system, APS, came around, Polybase was introduced, and that was a way to query, at that time, Hadoop data. So we couldn't really query anything else, but we could query against Hadoop. And Polybase shipped with SQL 2016. Azure SQL Data Warehouse added new and improved features to Polybase, and this then was we added that. Microsoft added that to SQL Server 2019, and we had quite a few enhancements of Polybase in SQL Server 2019 as well as in SQL Server 2019 Big Data Cluster. So something to think about here for you guys is that so the topic here, or the title, is data virtualization in big data cluster, but quite a lot of this can also be used from your standard 2019 installation. So in SQL Server 2019 we have enhanced Polybase, and let's have a look at what that is doing. So if we're then looking at data virtualization before and now, so linked servers, we can see what features it had. So one downside with linked servers was that they were instance scoped, right? So if we set up a linked server and we used it in a database, then we backed up that database and restored it in some other instance. Well, the linked server wouldn't work because the linked server may not be there, right? There are the queries are single-threaded. One cool thing with linked servers is that we are supporting pushdown. In other words, that so if we're doing aggregations, whatever, we can push that down to the source and have all that being executed there. Linked servers and always on in the availability groups, AG, that doesn't really work well together either. So if we compare this now to Polybase, so in Polybase, what we do is we are creating external tables. So we're getting like an SQL view over the data, wherever that data is and whatever type of that data it is. And we can see here some improvements over linked servers. An external table is a database scoped object. So yeah, so if you're backing up and restoring your Polybase external table will come with you. We are supporting bog standard ODBC drivers. I'll come back to that in a second. The downside with Polybase external tables is that at the moment I'm saying, it doesn't support updates. So it is read only. And Microsoft is working on that, and that will come in a later release. We can, as opposed to linked servers, my queries can be scaled out. We'll talk about that as well. So we can have multiple nodes of Polybase, and the queries will then be scaled out over those nodes and executing against the source. And since now the Polybase external tables are database scoped, well, availability groups will just work, right? So there are certain interesting things in Polybase external tables, especially compared to linked servers. Right. So SQL Server 2019, we said that Microsoft wanted us to be able to manage, integrate, and analyze all data. And SQL is now seen as a data integration hub, where we have our SQL Server, right? We have our SQL Server here. We have created some Polybase tables. And then in 2016, what we could do, as I said before, is that we could basically query against Hadoop. And that was either Hortonworks Hadoop or Cloudera's Hadoop. SQL Server 2016 also actually supported Azure Blob Store, but that was kind of the landscape back then. That this was purely, well, let's say NoSQL data where we are mostly looked at Hadoop. Now then, in 2019, we now have support for relational databases. So we can now create an external table over not only Microsoft SQL Server, but also Teradata and Oracle. Right? So no longer Hadoop only. We can go against relational databases. We also have native support for to create external tables over MongoDB as well as Cosmos DB. And then finally, and this is now SQL Server 2019 Big Data Cluster, mostly. Then finally, and this is huge, this is absolutely huge, in SQL Server 2019 Windows, so this is not big data cluster, but in the SQL Server we know and love, installed on Windows, we now have support for generic ODBC drivers. So in your SQL Server database, you can now create an external table over essentially whatever you have an ODBC driver for. And that is, as I said, huge. So Excel, hey, cool. Join, and obviously now, if we have an external table, then I can do joins, right? So I can do joins amongst other external tables, or I can do joins against my relational table in my SQL instance. An external table is just that, is a table. Right? It's almost like a view over the data. Right? And then also in 2019 big data cluster, we can do scale out through compute pools, which I will mention in a little bit. Right. So an external table then lives in the SQL Server. Well, SQL Server master instance. So it lives in, so this is now kind of a little bit slanted towards a big data cluster. So in a big data cluster, you have a SQL Server instance, which is kind of the SQL Server that you always have worked with. Then you have other SQL servers around there. So when we say master instance, this is really that this lives in your production test, whatever instance of SQL Server in one or more databases. The external table, as I mentioned, it represents a remote table or a view, right? So yeah, so when you're creating, we will see this in a second, when you're creating your external table, you're creating it according to what the remote data source looks like. And the thing here, once again, as this is now data virtualization, this is not data movement, we are not persisting any data in the external table. All the data still lives in the source table or Hadoop or whatever it is. And we are pushing down the queries to the remote source. We don't have to do a push down. So just something around that. So especially if you're using ODBC, generic ODBC drivers against some sort of remote data source. Sometimes, so when we're executing against an external table, the Polybase engine is doing some stuff with the query, and it translates it into something it believes that the remote data source understands. But that is not always the case. So for example, I had an example where someone wanted to do a top query, select top 10 against a SAP HANA database. And so the select statement was select top 10 from the database, and that works absolutely fine in SAP HANA. However, when he ran this as an external table with pushdown enabled, Polybase converted the query to, instead of doing select top 10, it was select star limit 10. Right? So for example, and SAP HANA didn't understand that. We fixed it by turning off the push down. But so that is something to think about. Anyway, so we need to configure this external table, and there are certain things we need to do. So for example, if we are accessing another relational database like Oracle or what have you, we probably need some sort of authentication, i.e. username, password. And so in that case, that has now to be defined in my database. And so what we have to do is we have to create a master key because we want something to protect this password. We don't want anyone, any Tom, Dick, or Harry to be able to get to that password. So we're needing a master key. So once again, that is if we need authentication against a remote data source. Credentials, obviously, once again, if it requires credentials, we obviously need to say where this remote server is. We also need to define the actual source, what is the database, or if it is HDFS, what is the directory, so on and so forth. Columns and types, obviously, right? What columns do we want back, or what are we retrieving here? And if it is NoSQL, we need to define a file format. And in big data cluster, we'll talk more about that on Thursday, but in big data cluster, the file format can be delimited text or Parquet files. Right. Actually, okay, so I'll swap over to demo quite soon. But so the file format, as I said, when we are using NoSQL, we need to define the file format. And the file format here is essentially telling us the actual layout of the data. And this is, once again, you don't need to do this for relational data, but for NoSQL data, you need to do it, right? So we can see here, down at the bottom, how I'm saying create external file format. I give it a name. It is the limited text. Format type is the limited text. What is the field terminator? So this is a comma. What is the string delimiter, etc., etc., etc. Right? Cool. What we then need to do, we have a file format. We need to create now, where is this data, or what server am I hooking into? So we are creating an external data source. And the external data source here essentially defines what connectivity protocol, credentials, whether we're doing push down, as I said before, type of data, and if we're doing Spark related things, we are also defining where the yarn, yet another resource manager, where the resource manager for yarn is. And then we're saying create external table. Cool. So let's do something here. Take down that. So I have, I've committed sacrilege here. So I have an Oracle database. So I run this all on Azure. So my big data cluster runs in Azure Kubernetes service on Azure, and here now my sacrilege here with Oracle is that I have that on a virtual machine, also in the Azure cluster. Right? So, and some of you may know about Oracle. I don't know very much. I'm trying to stay away from it. I kind of have managed to do that. But if you've done something with Oracle, you know that we have a table schema called Scott. And so, and that is a little bit like your, in the old days, once again, I'm showing my age here, but in the old days, we had the Northwind database in SQL Server, which was the canonical database. And Scott in Oracle used to be the same thing, the canonical table schema. So if I'm saying select star here from a table called emp in the Scott table schema, this will now take a while because my connection has been killed. We need to reconnect, and everyone knows how slow Oracle is. No, I'm just kidding. I'm just kidding. So we need to reconnect anyway. So what I want to do, yeah, my password is going to expire. So what I want to do is, so here we now see the result of my query. Here we're seeing having 14 rows. is an awesome table to do load and performance against, because whatever you're doing, you will have awesome performance. Anyway, so what we want to do is we want now to create an external table against this this table in my SQL Server big data cluster, right? So let's go in here to Azure Data Studio. If you haven't used Azure Data Studio is awesome. And one of the more awesomer, I don't know if that's a word or not, one of the more awesomer things is here, the notebook support. So I can basically create, so notebooks comes from the from data science, where data scientists use notebooks to collaborate. And the cool thing with notebooks is that you can interleave code with results with stuff, right? So in SQL Server Management Studio, when you're executing a query, the result lives for until you close down the query window or whatever. Here, if you want to, the result lives in your notebook. So this is ideal if, you know, when people are calling you for support and saying, hey, this does not work on I can't get this to work. And your answer is, more often than not, it works on my machine, because it does. So what we can do here is that this person now that has an issue, right, he can execute all this code, get the results back, being part of the notebook, send the notebook to you, and you can find out and figure out why this doesn't work. So what we're going to do here is I'm going to create a database, which I imaginatively calls Niels DPG, Niels Data Platform Geeks 3. I don't have any imagination, and at the end of webinars like this, I'm probably up at Niels DPG 99 or something like that. But anyway, so let's create this database. And let's connect to my big data cluster. And as you see here now, so here is now the result of this command, right? So let's do a use Niels DPG3. And as I'm now connecting into Oracle, I need to create this master key, because I need to protect credentials. So as it's, let's create master key encryption by password. That's cool. And now I'm creating my database scoped credential. This is kind of like a user or a login in your SQL Server, but you don't really have a user against it. It's just a credential, where I'm now saying my login name and the password. So don't look at the password, please, because as you can see, it's extremely secret. So let's run this. Okay, I have created the credential. And now I can create my external data source, right? Where the location is basically pointing out where is my server. And this is now, and I'm saying that this is Oracle. If it had been SQL, well, then it would have been SQL Server. If it had been Mongo, it would have MongoDB, etc., etc., etc. And I'm saying that this is now where I go to find the data, well, to where the database is that I want to retrieve data from. Well, I'm executing that. We have created an external data source, and now I can create my external table. Right? So we're saying create external table, and I'm just basically mimicking what the table looks like in Oracle. The one thing here is that this collation. So my Oracle server runs under UTF-8 collation, and my SQL doesn't do that. So I need to, I couldn't just say varchar 10 here, because that wouldn't work. I would get an ugly error. So what I need to say, because this varchar 10 or nvarchar for that matter, wouldn't match against the collation, so I need to kind of cast it to this collation. So let's run, let's run that create external table. And now we can see here. So actually, let's do this. Let's do this. select star from sys.tables, right? So I'm adding some code here, and sorry, let's get rid of that, and we can now see here that I have my table, right? That is emp_aura. Cool. So here goes the table. And since this will take a little while, well, it wasn't too bad. Look at this, right? So now my data now comes back, 14 rows, exactly as I had in the Oracle DB. And then if we're looking at how much space have I used here, run that, and notice, right? We're having 0 null rows, node memory reserved, etc., etc., etc. Right? So the data sits in the source database, and only the result comes back. Cool. There is another way, by the way. So I like scripts. I like to do things in scripts. But what you can do is also you can. There is an extension to Azure Data Studio where you can create an external table through a wizard. So and that works against SQL Server, and that works against Oracle. We're not going to do it here, but I'll just show you, hopefully, what it looks like. Here we go. So we're now getting a select data source. Do I want SQL or do I want Oracle? And then it's sort of a step through thing what you want to do. But as I said, we want so either you can use the wizard if it is SQL or Oracle, or you use scripts. At the end of the day, this wizard will generate the same code as you do in the script. Right, cool. So let's go back here and continue. So we've seen that. Now then, all right. So far, so this is now the extremely scary looking diagram from on SQL Server big data cluster, right? It runs on Kubernetes. If you were at my previous webinar, you would have seen it. We would have talked about it. And now, so what we have done so far is that we have been in this SQL Server, in what we call the master instance. However, I mean, you see how that is a very little part of a big data cluster. If we're now looking here, we're having something called a compute pool. We have a data pool. We have a storage pool, and also over to the left here, we have an application pool. So once again, on Thursday, we will talk a lot about data pool, and we'll talk about storage pool, right? Mention a little bit about compute pool, but just so you're getting a feel for this, let's talk about these pools a little bit. So a compute pool is where we are sharing out, where we're sharding out our queries. Dependent upon the data source you go against, SQL Server, the master instance can decide to give different SQL instances in the compute pool your query. It will be sharded out, and then the result will come back and be merged in together, right? So as I said, the compute pool contains a SQL Server Engine instance. We can offload stuff to local storage as now compute pool has a has SQL instance. We can offload storage to those instances if we want to do shuffling of the data or whatever. And as I said, we're having in the master instance, we have a scale-out query engine, which can now distribute queries across nodes in the compute pool. So a compute pool an example here is we have the user executes a query. The now distributed query engine here in the master instance decides that, hey, cool, we can do things better here, so let's offload this to the compute pool, and the compute pool is now may run 2, 3, 4 nodes and do queries against your underlying data source. So that was the compute pool. Storage pool, once again, we'll talk more about that on Thursday. Storage pool is interesting because that's where we have Hadoop. So when you are installing SQL Server Big Data Cluster, you are getting Hadoop out of the box together with Spark and together with some SQL instances. And so when you are storing data in HDFS, you will store it in the storage pool. You can mount against other Hadoop, on-prem Hadoop instances, whatever, and we can do data ingestion through Spark. And the interesting thing here is that we do not need to know HDFS in order to use this. But what we are doing is we are creating an external table against the HDFS data, and then we are querying it as we would any. Right, so let's have a quick look at that. Quick. So I have here storage pool, and I'm not gonna go through this in completely, but I just want to show you here. So in Azure Data Studio, we now see that we have an HDFS directory. And in this HDFS directory, we have a subdirectory called clickstream data. And when we are looking here now, I've created an external data source as we did with Oracle. Once again, Thursday we'll talk about what this is. I have creating a file system for CSV file. I could name it anything. And then I'm creating an external table against the SQL storage pool data source. This could also be named anything. It doesn't have to be SQL storage pool. And the location is now clickstream data, this directory. Right. So when I have done that, which I've already done, I can now do select top 10 here. And there we go. Here I now have 10 rows coming back from this data here. And when we're looking at this data, it will scream at me because it's a lot of data. It's around, I think, 500,000 rows or something like that. But anyway, come on. So the file has been truncated because it is too big. Come on. All right. So here is now the data, what the data looks like, right? And I happen to know when I created my external table, I knew what these various sort of comma delimited fields were, but I now any developer can now query this data. That's very, very cool, and do where clauses and do joins and do all kind of cool stuff. Right? So that's that. We then have this thing called the data pool, which is sometimes, right? Sometimes you don't want to. Sometimes you want to move the data. You want to cache the data. You want to cache it locally. So think about the data scientist who is who's creating models based upon millions and millions and millions of rows. He doesn't necessarily, and this data may not change that often. He may not necessarily want to actually query against the underlying data source every time he now runs some code to create a model. So he wants to cache this data in the local SQL instance. And that's where the data pool comes in. The data pool has one or more SQL instances, and they are now used for caching of data. And we can do scale out. So we are when we're ingesting data, we can actually round robin the data out across multiple SQL instances. And me as a developer, I don't need to know that that is happening. The SQL query engine handles that for me. So if we were to have a quick look at that, we are kind of running out of time. So I have here, once again, in Niels' database, I have here a query where I am joining against this HDFS external table that we saw before. Right? And in the database here called sales in my SQL instance. And I'm doing some grouping, I'm doing some sums stuff. Right? When I run this, you will see that this is now taking a little while because we are going down querying 500,000 rows in HDFS. We're trying to, Polybase is now trying to do cool things so we can actually run some, so we can do joins, etc., etc. And we can see that we came back with, this took 16 seconds. Right? And if we now want to cache this data, so let's say we can now kind of take some of the data and I want to cache it to make my query a little bit better. So I'm creating an external table that I called, once again, imaginatively, web clickstream clicks data pool. I am saying that I am doing a distribution of round robin, which means that when I'm ingesting data into the data pool, this will now be round robined out across the SQL instances that sits in the data pool. Right? I am doing some ingestion code. I have done some calculations here. I'm ingesting it into the data pool table. And then, so I have already done this, right? So now when I'm doing the same query, but instead of using against the HDFS external table, I am going against the data pool external table. And when I run this, I hope it works. Right. We're getting 100 rows back because I did select top 100. And we can now see that the execution time here was a lot quicker. 4 seconds versus, what was it upstairs? I think it was 16 seconds. Yeah, so 16 seconds. So here we now have cached data. And we can now see a scenario where you are actually wanting to now and then ingest more data, now and then maybe delete out data and ingest refresh data, etc., etc. And when we are looking at this, let's run a space used here. Actually, let's run this. So in SQL 2019, we also have a new, we can do execute at data source. It's a new command. And we're saying execute at the SQL data pool. So let's run that. Come on. And notice now how I'm getting back to web clickstreams data pool tables, because I have two data pool in two SQL Server instances in that data pool. And now when I created this data pool table, I didn't have to do anything, but the underlying framework handled it for me, created one instance, one table in each of those two SQL instances. And if we are looking here at, we're executing space used, come on, we will now see that we actually have data in these two tables. So 292,728. So we have around 600, well, we have quite a lot of data, so 500, 600,000 odd rows in together, but they are now sharded out across those two instances. But me as a developer, I don't need to know anything about this. I'm just doing a select, where, whatever, right? Cool. And once again, Thursday, I recommend warmly join up on Thursday, and we'll talk more about what we are doing here with the storage pool and the data pool. And the summary then, we're coming up to the end. Moving data between systems has many drawbacks. We've talked about it. It costs, it can be compliance, whatever, right? In many circumstances, it may be better to be able to reference data where it lives, i.e. in the source system. And through Polybase, we get external tables. And then we are creating external tables against relational databases, Hadoop file system, blob store, etc. Storage pool persists data in HDFS, and the data pool allows me to cache data, to ingest data, and distribute that data across various shards. And that's that. So I want to thank you guys for taking time coming and listening to me. I know you have a busy life, but you rocked up. That's cool. And I want to also thank a very, very warm thanks to Data Platform Geeks for doing this for the community. They are doing an awesome job. And please, please, please make sure, tell your friends, tell them how awesome Data Platform Geeks is, and make them sign up for Data Platform Geeks. Once again, thank you guys.
Thank you, Niels, for the wonderful webinar. And I request all the attendees to post your questions using the Q&A panel. Meanwhile, let me just walk through a couple of slides. A quick word from our knowledge partners, SQL Maestros. SQL Maestros is coming up with video courses, SQL Server Performance Tuning, T-SQL Querying, and T-SQL Programming. It is going to be an advanced deep dive video course which you can watch anytime, anywhere, and as many times as you want. If you wish to learn more about the upcoming video courses, you can visit sqlmaestros.com, or you can drop an email to contact@sqlmaestros.com. One of our team members will reply to it. SQL Maestros has relaunched its hands-on lab subscription model. Now, once you purchase the labs, you can own them for life. Hands-on labs is a document-based learning where you'll be provided with the document with step-by-step procedures, instructions, explanations, screenshots, and scripts. So by the end of the document, you'll be able to become an expert at that particular topic. So right now we have more than 100 labs on the technologies related to SQL Server, Azure, Power BI, Analytics, Cosmos DB, etc. So you can go ahead and visit SQL Maestros HOL's page. So there are a couple of free labs available in the website. You can download them and practice them, and then later move on to if you need to purchase. So with this, we are going to conclude the webinar. We have posted a thank you message on our LinkedIn and Facebook pages. The links are available in the chat window. And the LinkedIn link and the Facebook link. I request you all to please go ahead and leave us some comments or feedback, which will definitely encourage our speakers to come back and deliver more sessions. So the links are available in the chat window. Niels, I guess you can take over for the Q&A. I see there is a question there.
Yeah, so there's one question about sharing of the slides, and absolutely later today, potentially tomorrow, I have a work to go to. I need to go into work now, but I will definitely share these slides. And as I said also in the beginning, I will share the code as well, so you can have a look at what it looks like. And if you have any questions, please feel free to ping me directly, or even better, ask your question on those links in LinkedIn. That way the whole community can get some information, and we are knowledge sharing.
Yeah, you can post the questions in our social media channel as well. We'll get it to Niels if there's any question there.
Exactly. So it's probably better that you're asking on the social media channel, because that will then be available to more people.
Yeah, sure.
But once again, if you don't want to do it, please, you can ping me directly. That's not a problem at all either.
The webinar video will be shortly available in our YouTube channel. and you'll be getting a mail with the resources as well. I guess there are no more questions.
It doesn't look that way. So with that, I'm saying thank you guys. Thanks again for taking time coming here, and thank you to Data Platform Geeks. See you on Thursday.
Yeah, thank you so much, Niels, for taking out the time for our community. And to all the attendees, we have many more webinars lined up this week and then next month. And we have an in-person event on March 14th at Bangalore, Microsoft campus. So you can just visit our events page, www.dataplatformgeek/events. Thank you, Niels.